Okay, now let's define the proper time. Let's call that delta t sub 0, delta t naught. That's the proper time. Let's define that to be the time between events happening at the same place in a particular reference frame. In Einstein's Gedanken experiment that we've just considered, the whole action of the light pulse reflecting and then being detected basically at the same place measures out a particular time interval in the rest frame of Anna, and so we can think of it, as I said before, as a light clock with the proper time delta t sub 0, delta t naught equal to delta t prime, the time measured in Anna's frame. Okay, this allows us to generate a general expression for time dilation, which is that delta t, the time interval measured in any moving reference frame, is equal to the Lorentz factor gamma times the proper time. Okay, gamma is defined here, where again the proper time is the time interval measured in between two events that happen at the same place in a particular other reference frame. Okay, so this relates the time intervals in any two reference frames. Okay, any two reference frames that are moving with respect to each other, and so it's a general expression for time dilation. Okay, in words, we can this mathematical relationship which we just described, in words we can write it like this: the time interval delta t that passes between two events in another reference frame is longer by a factor gamma than the interval delta t naught in the frame in which the events occur at the same location. Now this is a very general result, so even though we derived this with using Einstein's Gedanken experiment, it is true in general for any two inertial reference frames that are moving with respect to each other whenever a proper time delta t sub 0 can be defined. Now, some of you may be wondering at this point whether we have violated relativity, in the sense that we have identified a preferred reference frame. After all, why does Anna's clock run slow only for Bob and not for Anna? I mean, Anna and Bob are in completely symmetric reference frames, so why does this happen? Doesn't this imply that we have a preferred reference frame, which, as we've discussed before, is not allowed under relativity, special relativity, or Galilean relativity?